Hello students, welcome to the Yupp Master. Today we are going to deal the very interesting topic regarding to the NTSE examination. So we would like to take that physics. It plays an important role to have the success in the NTSE examination. Let's have a look. Yeah, measurements. So this is one of the chapter for your examination. We would like to know the importance of the measurements and the concepts which are related to different system of units to measure the physical quantities, to express the value of the physical quantity in different system of units. So they are all going to frame the problems regarding to these measurements, right. Suppose if you are going to take that, what do you mean by physical quantity? All the quantities are going to be physical quantities. The only measurable quantity, it's a measurements are going to be taken. These are known as physical quantities, right. If you are going to start with that, just see that, yeah, system of units for the measurement of physical quantities. You have to know about that. The quantity represents how much, just you have to take this one. Yeah, if you are going to take that quantity, that represent how many, how much, right. Yes, we have to take that. Just we are going to talk about that, that is the quantity. But when you are going to take that physical quantity, yeah, a measurable quantity, is known as physical quantity. Just we have to known as physical quantity. That is very clear. Right. It is very clear. We are going to take that what we are having that present topic. We have to digest that topic and then we will go in deep. It is very clear. We are having the system of units which are defined in earlier 1971. After 1971, they are going to take under the common domain of the SI system. It is very clear, and measurement is a process. Just we are going to take that. It is a one process which has been involved in various steps. You have to choose the standard unit and known quantity, unknown quantity. They are going to be taken. With the known quantity, the measurement has been taken. It is very clear. The physical quantity is nothing but measurable quantity. Suppose if we are going to take that, the strength of electric current is measurable, the electric flux is going to be measurable. At the same time, if you are going to take that, work done is measurable. At the same time, if you have taken that, the surface area of the amoeba is not at all able to measurable. The total space occupied by an octopus is measurable. Is it not possible? Right. For the measurement process, some physical quantities are going to be independent, some physical quantities are going to be dependent, right. So it is very clear, the fundamental quantities are independent, the dependent quantities are derived quantities, all right. Let us go for that. If you are going to take that universe, it is also one of the chapter for your entrance exam in the domain of physics. You know, time if you are going to measure the time, universally you are going to take that at different planets the time is going to be varied, and the revolving path, radius of that orbit, all these are measurable quantities, the size, mass and all these things. Let us see. Yeah, need of measurements. So, in order to have that some estimation like mechanical properties, electrical properties, magnetic properties, all these are going to be measured in order to have the different activities in our daily life. In order to engage that daily activities, you need to have that different measurements. Please see that. Yes, in order to estimate the following in our daily life, measurement is necessary. So, without measurement you can't survive that life, right. So, physical properties, if you are going to take that physical properties, yeah, while you are going to talk about that physical properties, just you have to take that it is a density, yeah, volume occupied by the atoms, volume occupied by atoms, it is also measurable. If you have taken that matter that is of solid, liquid, gases, you have taken all these things. In order to estimate their mechanical properties, you have to consider that following, that is density, yeah, volume occupied by the atoms. Yes. So, you are going to take that, you have to take that mass by volume occupied by the atoms. Suppose you are going to take that the distance between the atoms in case of the solid, liquid, gases. When you have taken that one layer of the solid, one layer of liquid, one layer of the gas, how they are going to transmit the pressure, how they are going to transmit the heat energy, you have to estimate. All these are at the time, if you are going to take that coefficient of viscosity, and if you are going to take that thermal conductivity, electrical conductivity, all these are very important, you need to know about this one. So, while you are talking about that physical property, just you have to take that force by area, you are going to get this force by area, yeah, you have to get that pressure. So, if you are going to take that work done, suppose you have taken work done, that is equal to force into displacement, these are all interdependent, you need to take that. At the same time, work done is in the form of energy, work done is nothing but energy, you have to confirm. If you are going to take that energy, yeah, at the same time you have to consider that potential energy, all these are going to be under these physical properties. So, if you are going to talk about that physical properties, there exists a size, that is a regular size. All right, please have a look. If you are talking about that physical properties, there exists a size. Yeah, if you are taking that length, breadth, height and mass, if these are all having, it will occupy some space. In that material, you have to talk about that arrangement, that is mass by volume, that gives the density. Different materials are having the different densities, just you have to confirm that. In order to have the different mechanical properties and physical properties, all these are need to know about, you need to know about all these things. Suppose they are going to ask that joule, what about that joule, if you have taken that joule, Yeah, that is going to be derived unit of energy. You have to take that 1 joule. Sometimes you need to convert into X, right. You have to take this one. Just you have to get this work done by the body. So, you need to take that 1 Newton meter. You have to get that expressions, and while you are going to solve the problems, you need to know all interrelated formulas. All right, let us go for another one. Yeah, that is mechanical properties, already we have discussed. So, per unit area there exists a force acting on the material. So, there exists a sharing of the force into different layers. How you can talk about all these mechanical properties by means of some fundamental laws, right. Next you can go for that, yeah, electrical properties. While you are going to take that electrical properties, you need to know about that conductivity, resistivity, yeah, conductivity and resistivity. If you are going to take that, it has been given some external voltage, just you are going to take this one, right. You have to give that electrons, yes, you can get that conductivity just. At the same time you need to measure that resistivity also, its dependence. Especially you are talking about resistivity, how does it varies with temperature? Dependence. Yes, the number of electrons are going to displace bearing the resistivity. At the same time you need to get the different formulas, right. If you are going to talk about that, J is equal to sigma E. J is the current density. You have all these concepts in your lower classes, but once we are going to recap all these fundamentals, it is very easy. So, yeah, J is the current density, sigma is the electrical conductivity, that is E is the applied field. Just you are going to get that similar law, that is V is equal to IR, right. Just we have to take this one, right. So, these are all different concepts which are very, very important for the measurement. You want to get that strength of current when you have been apply that potential difference of that 10 volts or 50 volts, whatever it may be, how does it will varies. So, you are going to get this sigma is equal to n E square tau by m. These are all the laws that we are going to get that. So, due to the collisions among the various number of electrons, there exists a resistance. As the temperature increases, that will changes. It is very clear. That is what I am telling you. While you are taking a one concept, you have to get that very deep knowledge. That is very, very important. Please note that. All right, let us go for another one. Magnetic properties. It is very clear, if you are going to take that, electrical properties and magnetic properties both are going to be interrelated. Many concepts have been derived to explain the relation between the electric and magnetic fields. Yes, mostly we are going to talk about that Amperes law, how that current carrying conductor having that magnetic flux around it, just it is going to be exhibit that current carrying conductor is having that some magnetic behavior. Alright. That is what if you are going to take that magnetic properties, especially if you are going to take that magnetic properties. Yeah, this is going to be magnet, just we are going to take that how the flux is going to be entered. Just we have to get this one. So, the flux per unit area, this is a flux by area, that gives the magnetic field induction. Already you have been studied in your lower classes. That is what if you wants to measure the magnetic field induction, that is B, it has been represented the magnetic flux per unit area, that gives the value of B. And if you are going to place a one magnet, one material, what happened? Just we have taken, they are going to be, just we have to take that. If you have taken that one material, just some flux penetrated, flux entered. Yeah, it depends on magnetic field intensity, that is field intensity. Alright, what I am going to convey to you, just listen. There is a magnetic field if you have been placed a one external material, that is one object which is going to be magnet or non-magnet, that is a secondary. If you have been placed in the field, some magnetic flux is going to be penetrated, then you can feel it is a, it behaves like a magnet. Alright. So, it depends the strength of the field. Alright. That is what if you are going to take that, these magnetic properties are estimated. In your daily life you are having that so many applications of this magnetic field. Right. Now, if you are going to take that basic relations also very important, that is if you are taking that B is equal to mu H, right. These basic relations are very useful to solve the problems. So, you are taking that B is equal to phi by A, that is flux by area. It should be expressed in terms of that Weber per meter square in SI system of unit. Weber, that can be used to represent the quantity of the magnetic flux, right. That is what you have to take that. Yeah. If you are going to take that H, it is represented ampere per meter, just you have to take. These are all very important relations, and their representation in different system of units has been discussed here. It is very clear. That is what we are going to take that physical properties, mechanical properties, electrical properties and magnetic properties. At the same time, lastly we would like to discuss that optical properties also. Optical properties. Just you have to differentiate that opaque and non-opaque substances. So, how the substances are going to be transparent to the light. Yeah, this is the fifth one, let us take that. It is very clear. You have to estimate that optical properties. So, one substance is going to be transparent for the incident light rays and allow the light rays. You have to identify that reflection of light. At the same time, refraction of the light is also going to be considered. If the light rays are entered from one medium to another medium, the refraction plays important role. It phenomena existence. Alright. At the same time, if you are going to take that optical properties, you need to talk about that angle of refraction, angle of reflection. At the same time, if you are going to take that light intensity, it can be calculated, it can be represented by that SI unit candela, just we have to take that. Lux, lumen, different system of units are there, but you have to remember all these units. It is very clear, that is what we are going to take that measurement. Yeah. Now, if you are going to take that optical properties, that is also included in your chapter. Yeah, you have to take that light intensity, reflection, refraction, diffraction, interference, and polarization. It is very clear. Now, I am going to tell one important point. This is one that is a new concept for you. These are all properties which are going to be exhibited by the sound waves, all right. Why we are going to know about this one? Polarization. Polarization. We are going to take that sound waves. So, from the source they are going to emit in all the direction. But if you are going to take that light waves, you can talk about that. From the source they are emitted, they are going to be confined, they will confine to a one plane, it is a possible. They are confined to a one plane. Is it possible to trap the sound waves in one plane, not to go in all the directions? Just you have to think, that is very, very important, right. So, the light waves are confined to a one plane, that phenomena is going to be known as polarization. It is very clear, but the sound waves are not to be exhibited. So, we have discussed all that properties, yeah, within short period of time. It is very clear. So, polarization means the light rays confined to one plane, light rays confined to one plane, This phenomena is known as polarization. Is it possible? Right. Okay, let us go for another one. It is the only one thing that has that the sound waves and light waves are going to have the difference. You can get that refraction, reflection, interference, diffraction, all these things. Only that the speciality. You have to know that there may be a chance to ask these type of questions in entrance also. They are going to get that concepts. Right. Let us go for another one. If you are going to take that universe, how it is going to be having that interactions by means of the force, yeah, that force which binds all together and they are going to move with the constant speed, even though they are going to exhibit in their path. Just you have to see that. We are going to talk about that. We are here only, just we are, yeah. It's very clear. We have to know about that time taken just while taking that light year. We have to know about that light year and all these parameters. Let us see. If you are going to take that, yes, you have to calculate that time. While you are going to talk about the time and its conversions, just we have to see that. Yeah, what we have discussed about that magnetic flux, let us see that. They are going to be originated from the north pole and they are going to get end at south pole, and these are the concentric circles, like they never leave the space, this is a magnet, they will move and they are going to moving in the surroundings only. Now, if you are going to take that, this is the flux what we have discussed. Yeah, this is the area. This is the area what we are going to take that. Let us assume. So, this is the magnetic flux. This is the magnetic flux. So, if the magnetic flux is nothing but magnetic lines of force, if more number of magnetic lines of force is there, then you can feel it is a strong magnet. Around that, its influence is going to be felt in terms of more number of magnetic lines of force. How does it will attract very strongly? If the magnetic number of lines are more, then it is having that strong magnetic field. All right, that is the case. So, we have taken this area. While you are going to take that magnetic field induction, you wants to measure that magnetic field induction. B is equal to flux per unit area, flux by area. It is very clear. Sometimes they are going to be represented, B is equal to phi by A. Phi area is A. Yeah, in this area the amount of flux has been calculated, that gives the field induction. All right. Now, if you are going to take that unit is Weber per meter square. All right. It is very clear. That is what we are going to know about that magnetic properties. All right. Let us go for another one. Just we wants to know about that mechanical properties. Just we have been apply that force. How does it shares that force to another layers or another atoms like. So, you can take that force per unit area, or otherwise you have to take that force into displacement. Yeah, that gives that work done. All right, just we have to take this one. So, this work done, just we have to take that. At the same time, if you are going to take that pressure per unit area, just you have to take that pressure is equal to force per unit area. While you are going to talk about that power in case of that electric properties, just we have to take that W by T. It is also very clear. Later we would like to know that. Yeah, work done. While you are talking about that work done, so just you have to estimate all. Right, let us go for electrical properties. All right, it is very clear. We are going to take electrical properties. Just you can see, yeah, how the charges are going to be displaced by applying that potential difference. Just we are going to measure that current. We have to take that strength of current, that is I is equal to Q by T. These are the basic laws, that within the time interval of that how much amount of the charge, how many number of charges are going to be displaced, that gives the strength of current per unit time. Just we have to measure this one. Right, it is very clear. It depends on that V, that's potential. You can take that dependence of linear dependency of that current with the voltage according to that Ohm's law. It is very clear. Right. Let us go for another one. Let us see. It is very clear. What do you mean by physics? Just you have to define with your own way. Yes, physics is the branch of science that deals the interaction of the force, internal force or external force with the matter, which may cause or may not cause for their motion. All right, just you have to see the interaction of the force is a branch of, just you can see that. Yeah, we are all going to talk about that branch of science that deals the properties and mechanical interactions, mechanical interaction with the matter with external internal forces which may or may not cause for their motion, right. It is very clear, we are going to get that. All right, and you can take that any part, just electrical properties, mechanical properties. So, the mechanics is the branch of physics, all right, we will agree. If you are going to take any domain, it is the branch of physics. We have to take that interactions, right. Yeah, in physics, just we have to get that experimental observations and theoretical approach that gives the success. If you are going to have that any hypothetical truth, it should be in the form of an experiment and it should produce the correct results with theoretical and experimental approach, then only we will agree. It will come into the form of one statement or one form of expression or one law, fundamental law. All right, that is what we need to get, that observations, experimental observations and mathematical analysis, that is very, very important. We are going to talk about that experimental observations. Need of measurement is also considered. All right, shall we go for the problems, right. While you are going to express that derived quantity, yeah, it is going to be derived quantity. So, its value is going to be expressed, P is the magnitude, N is the numerical value, U is the unit. So, the magnitude does not change if you even you can express in any system of unit, all right. Now, it is very clear, it is a form of expression simply, yeah, standard unit of that quantity, right. All these are all system of units you have been studied, you are having that familiar knowledge about this system of units, all right. So, what we are following, that international system of units, SI systems, that in 1971 they are going to taken a common domain of that the fundamental quantities, right. Just we have to see that. Yeah, if you are going to take these fundamental quantities, they are going to be, yeah, length, mass, time. Already previously these are all the fundamental quantities, these three are there involved in that system. So, they have taken that strength of current, thermodynamic temperature, they are going to electrical properties and thermodynamic properties, and amount of substance has been measured, that is mole, and luminous intensity just you have taken candela. Apart from, in order to describe that the motion of a particle in a plane around the circular orbit, they have taken that angular displacement. In order to explain the different kinds of motion, they have taken some supplementary units, that is very clear, they have taken that supplementary physical quantities, all right. So, plane angle and solid angle, it is very clear, right. For their purpose is in order to explain the motion of the particle or any planet or whatever it may be in 3-dimensional space in 2D plane. So, especially solid angle is useful for that 3D explanation, it is going to be 2D in circular motion, yes, to measure that angular displacement, all right. Let us go for this angular displacement, we will see. You have to get this angular displacement. Just you have to see that now. This is a plane angle and this is a solid angle. Yeah. The angle subtended by a unit area in the view with respect to the 3D space. It is that angle subtended with respect to the coordinate axis in a plane. It is in 3D space. Alright, that is what we have to take. So, especially if you are going to take that, you wants to express that, yeah, the light rays which are spreaded in all direction in 3-dimensional space. So, the light rays entered, the light rays per unit area. If you are going to get this from the source, so the light rays are going to be measured, yeah, like that. You have to take this one. In any direction they are going to move, right. Yeah, you are going to take this one with respect to this area, angle subtended by the area, that space, 3D space, you can measure that. So, here we would like to take that solid angle, it is very clear. So, unit is going to be steradian, alright. Let us go for another one. Yeah, previous NTSE problems. Okay, let us discuss about this. As a unit of work, if you are going to take that work, that is force into displacement. Yeah, it is very clear. If you are going to take that force, it has been represented by the derived unit, that is Newton. You have to take that Newton. So, while you are talking about the displacement, it has been measured in terms of meters, yeah, or in SI system they are going to be measured in terms of meters. It is a basic question. So, it is a Newton meter, just you can see the answer. So, this is the correct answer, very simple question. Let us go for another one. We have to take that 1 Newton into dyne. Yes, if you have to take that, what is the answer, just you have to see. Okay, let us see. Right, if you are going to take that 1 Newton, it is a derived unit to represent the force in SI system, right. And if you are going to take that dyne, it is a derived unit to represent the force in CGS system, alright. Okay, we can take that. Yeah, if you are going to get this one, you have to take that, yeah, 1 kg, just you are going to take that meter per second square. It is very clear. Now, if you are going to take that, very clear, alright, just you wants to convert in SI system of units into CGS system, alright. Just if you are going to take this part, we have to take this one. How you are going to express in CGS system, just you have to take that. So, it is going to be converted, you know, yeah, 1 kg is equal to 1000 grams, that is 10 power 3 grams, alright. Now, if you are going to take that 1 meter, that is equal to 100 centimeter, 10 power 2 centimeter. So, if you are going to take that time second, it is going to be same, just it is going to be, no need to take this one, we have taken second, that is very clear. Just you have to take that application, 1 Newton is equal to 1 kg meter per second square. So, while you are going to get that conversion directly, you can get that conversion, that is 10 to the power of 3 grams, 10 to the power of 2 centimeter per second square, just 10 to the power of 5. Alright, just you will get this one. So, 1 Newton is equal to 10 to the power of 5 dyne. Very clear. What's the answer? Let's see. Yeah, this is the answer. We are going to. In this way, you can convert. You can do all these things. It's not a big task for you. All right. Now we would like to go for that next problem. Let's see. Yeah, if you are going to take that mass is going to be converted into energy. All right. That mass is converted. If you are going to take that matter, it is nothing but matter which is in the solid form. When you have been supplied some external amount of heat, what happened? It is going to be converted into liquid state. It meets different states, that is going to be solid to liquid, liquid to gas. Just you have to take that. So, you need to get that matter is going to be converted into energy in its form. Right, just see that. If you are going to look this matter, you can easily identify that. It is very clear. While you are going to solve the problems like conversion of mass into energy, and while you are going to take that thermodynamic temperature and its variations, liquid state, it is going to be very clear. Yeah, it is going to be converted into, as the temperature increases, what happened, you need to see about that. Only the temperature gradient, just the change of temperature is only the one reason to exhibit that matter in different states. That is very clear. Yeah, it is clear, just you have to take this one. Right. Let us go for another one. Convert 1 joule into erg. You have to take in that, right, these are all the units for the representation of energy, all right, in different systems, that is SI and CJS. It is very clear. You know, 1 joule is equal to 1 Newton meter. While it is going to be taken energy, so the form of work done, it's a form of work done. Just you have to take that. It's very clear. It's better to write here. Now you have to take that work done. Work done by the body is in the form of its potential energy or its energy. It's very clear. That is equal to force into displacement. That's what we have taken Newton meter. All right. It's very clear why we are going to take all these phenomena. It is to have that clear information for you. Then it is very useful for another problems also. That's what. So 1 Newton meter is there. If you are going to take that 1 Newton, that is 10 to the power of 5 dynes. Already we have taken that. So 1 meter, it is going to be 10 to the power of 2 centimeter. It's very clear. We are going to talk about that. 10 to the power of 7 egg. So yes, all right. Just we have to see this. It's very clear. Let's see. Yeah, 1 Newton, 1 joule is equal to, just you have to take 1 joule is equal to 1 Newton meter. It is going to be taken. This is the CGS unit for the representation of energy. Otherwise, you can write like that only. If you wants to represent 1 kg meter per second square into meter, just you can represent in the form. It is not a big task for you. Okay, students, in the coming classes also we are going to discuss in a different way to have the success in your career. Thank you very much. Have a nice day.